Now, here is a disclaimer. As much as you as a student would have it in mind that it's only what you are being told or what you are being taught that will serve you excellent success, big success, then you would be deceiving yourself. As much as possible, for every effort we are pushing at you on this platform, you also want to make that conscious effort yourself to always go over what you have been taught. And it is on this note that I want to announce to you, everyone listening to me, please, we are here to serve you. We are not just here to just throw topics at you, throw formulas at you, among other things. This is what I need you to do for me. Come next class, we want to launch the month of April in a kind of modified way, such that from next month, certainly this would be the last time we'll be having the class for this month. From next month or before next month, before our first class next month, I expect that students on the platform should have written out a list of topics they don't understand. Okay, not the day. You don't understand. List of topics you don't understand in physics, which you want us to revise. Which you want us to revise. Remember, we are here to serve you. So it's not just a question of we are just picking topics from our side. We want to be sure that all the topics we are giving you are actually meeting the basic critical aspects of what you are doing. So please, gather the topics together. All you are going to do is pick your physics syllabus, get to write out all those topics, start ticking them one by one, tick them one by one. Okay, motion, I'm good to go. Wave, I'm good to go. Friction, I'm good to go. Power, I'm good to go. Resistivity, I'm good to go. AC and DC circuits, I'm good to go. Talking about half-life, I'm good to go. Just pick those topics, the list of all the topics given to you based on your Jamb syllabus. Tick out those ones you are sure you've been able to cover. Those ones you feel you still have issues with, try to drop them on the WhatsApp group so that it's easy for us to collate everything within the space of this week before next class, such that our focus will now be what? Dealing and tackling questions from those areas. With this, we'll be able to what? Effectively cover at least over 80% of the topics you have before you during your what? UTME examination. Remember, your success remains our major priority. We are interested in seeing you what? Doing wonderfully well. Even without our efforts here, some of you might be able to pull off a scale of 200 over 400. But we don't want to settle for what? The average score. We're aiming for what? A bigger range of scores. Tell us, oh, I was able to net 280. That's beautiful. I was able to net 305. That's beautiful. Remember, the higher your Jamb score, the lesser the effort you need to put into your post-UTME, meaning you will not start struggling. And you know that kind of euphoria that students will be having. Imagine a student telling you, for example, University of Lagos, a student telling you something like, oh, based on what I score in my Jamb score, I need like 30 over 30 in my post-UTME in order for me to gain admission. Auntie, brother, 30 over 30, yes, it is possible. But why did you put yourself in that tight position that you have to pursue 30 over 30 when you could have scored higher in your Jamb score and you just need something around 22 over 30 and you are good? Anything beyond 22 over 30 is a plus on your side. Please remember, your Jamb score contributes 50% of your total aggregate. Your total aggregate, your Jamb score contributes 50% to it. That is why you see us put much effort into ensuring that what you have the highest of marks in your what? Jamb. So here is it. Take out your what? Syllabus. Write out a list of topics you don't understand in physics, which you want us to what? Revise. Let's put and compile all that together before next class, so that from next class, we start hitting the nail on the head. We are now addressing the leftover topics. We are not just, oh, I pick a topic, oh, I know that topic, Jerry, I'm not interested. Oh, this one, I know this topic, I'm not interested. We don't want that case scenario. We want to be sure that we are meeting your exact need. So please, remember, list of topics out of the syllabus of Jamb, which you have remaining. At least that will help you to estimate what your capacity, preparedness level is. Out of maybe 37 or 38 topics in Jamb, if you are able to have netted around 24 or thereabouts, you know how you feel. Oh, you've netted 27 out of 37 topics. Okay, you know, okay, you are getting there. So let's take a statistics to be sure that we are making progress in the right direction. In having said that, we can now what? Pick these aspects. I'm sure that many of you are already familiar with the topic friction. But are you very, very conversant with how Jamb structured questions around friction for you? Are you familiar with the fact that everything with regards to what UTME examination questions will be asked, every question under your UTME examination, it is structured under 4 types of what? Friction questions. Are you familiar with the fact that what? Friction, at this stage, you shouldn't be treating friction as a topic. Oh, friction has been friction. I'm cramming F equals to UR. I'm cramming, oh, it's just for me to pick R equals to mg, or to pick coefficient of friction as being equal to tan theta. No, my brother, no, my sister. It is high time you know your what? Friction as a topic based on what aspect of what? Physics did it come out from? Number 1. Number 2, what are the subcategories of questions under friction that Jamb is asking you? Number 3 thing is that what? What is the structure of friction as a topic that I will still meet in the university? We are not finishing just what? Yet, as far as what? Your O-level examinations are concerned. We are launching you such that what? You are well fitted and grounded in physics what? Concepts that you would use easily in your what? Universities when you get there. At least I can tell you categorically that what? Over 70% of what? Universities in Nigeria, in your first year, year 1, you will be what? Treating Atwood machines. Atwood machines. And trust me, Atwood machines are just what? Two masses which are connected by a single what? String under the concept of what? Friction. It is this foundation of friction from your Jamb they want you to know very well and solidly well, such that you can tackle questions with regards to what? Your year 1. So let's get right into it. What do we need to know talking about friction that relates to our UTME examination? 4 important things. I repeat, 4 important things. Check it out. Maybe peradventure you already know friction, but you know it's scatter, advantage of friction, disadvantage of friction. Most times UTME does not ask you that though. They don't focus on advantage. They want the calculation. There's plenty things that they can ask you. You have enough questions calculation-wise under what? Your friction, talking about the 4 categories of what we are looking at. So check this out. Friction as a topic. Now, you have some of your friends that are not here. Better call them and tell them, come, there's a new dynamics to what we think about friction that you need to actually what? Learn. So that they won't just say the topic friction and friction, I know friction. Please, call their attention. Let them know that there's something new or something extra that they need to what? Add to their sleeve of knowledge. So this is it. Already we are told about 2 things that the man named Newton created. A very wonderful scientist that dived into different aspects. You remember and you recollected that what? From SS1, they gave us this guy, Newton, coming up with what? Equations of motion. equations of motion. This guy came up with equations of motion because when you know the history of what happened in the past, then you can structure the future into what you want it to be like for you. When you know where friction came from and how the whole concept of motion works, you don't look carried away or lost whenever you see questions being thrown at you. You know exactly what you are doing, and that's what I want of us today. Now, equation of motion came about through Newton. He carved out what we started learning from our SS1, talking about the 4 equations of motion. We talk about V equals to U plus or minus AT. We talked about S equal to UT plus or minus half AT square. We talked about V square being equal to U square plus or minus 2AS. And lastly, we talked about S equals to what? V plus U in bracket of T divided by 2. The 4 equations. Now, listen good. All these are under the part we call kinematics. Kinematics. What is kinematics? The study of motion without consideration to the force causing the motion. We are studying motion without consideration to the force causing the motion. Kinematics. The branch of motion which studies motion. So when you get to year 1, you would remember Mr. Femi and you'll be like, oh, FM said this. It will just be, you will just be having the flashback and the playback. Oh, FM has given me hints, heads up as regards this aspect. So in your year 1, you know you are good to go. You don't have anything to worry about talking about this part. So kinematics is the branch of motion that deals with what? Study of motion without, note, without consideration to the force causing the motion. That is why 99% of the time, you will never see them give you question with regards to equation of motion. And they will be asking you to calculate mass inside the equation of motion. Are you following? Yes, there might be a combination of kinematics and the other parts that has to do with mass. They can combine them together. But once it is kinematics alone, once it is equation of motion alone, trust me, you are only to use any of the 4 formulas. That's all. Everything you are calculating under equation of motion is limited to velocity, acceleration, time, and distance. That is what is evolving. Everything is evolving around that aspect. You already know that. The second part, which is not in high demand, which is not emphasized most of the time, is this guy, which we call dynamics. Don't worry, big grammar, be dynamics. Let's break it down to something you can relate with. Have you heard of Newton's laws of motion before? Now you can relate, isn't it? Good. Our teachers in school might not have done that justice for us to have told you, okay, this is how this topic is linked with this topic. This topic is linked with this topic. In university, that's what they want you to know. How one topic relates with another topic. That is when you have a grasp, a full understanding of what you are dealing with. We have dynamics, which talks about what? The laws of motion. But you trust, in SS2 back then, all they just told us, Newton's first law, Newton's second law, Newton's third law. Oh, Parisibe. Guy, wake up. The calculation aspect under Newton's law is this. That second law that they gave us, that they said that what? F is equal to MA is very important. F equals to MA is one law you want to play with and understand the nitty-gritty. The second one is that what? W equals to mg. It is these 2 guys that form the foundation of what you'll be dealing with, talking about friction. Talking about friction, the 3 things you'll be dealing with. And remember, let me remind you, we said that to every action, there must be what? Equal and opposite reaction. When they slap your face, you'll not be shining your teeth. Abina, You would what? Respond. It must be equal and opposite to what you are experiencing. That is what Newton's third law is telling us about. So it's on the basis of Newton's third law that we carve to every action equal and opposite reaction. That is why we now said that the 4 branches of physics, friction, 4 branches under friction, which we study, include number 1. Number 1, Jamb want to ask you question. They will talk about motion on horizontal surface. Motion on horizontal surfaces. Don't be scared. When you know what they can ask and what they cannot ask, you will blast the exam. You don't get. It's when you read one aspect, you go and carry textbook in your front and you are just cramming and dubbing everything in your head. You would feel you have read, but at the same time, you'll be telling yourself, hope what I read will come out. So here is it. When you know what can come out and what cannot come out from a topic, you have that confidence. Motion on horizontal surfaces. What do you need to know? Jamb will ask you a question and tell you that a car is moving with a given force. When car is moving on the road, we expect it to be horizontal. Now, for every action, there must be equal and opposite reaction. So when that car engine, the engine of the car is causing the car to move forward with a force F. Here, the car is moving forward in this direction. You must have an equal and opposite reaction that wants to stop that car. And it will come in our everyday life as what? Wind. That's why when you are driving on the highway and you have your glass wind down, what happens? The breeze will just be pouring in. And what happens? You have to wind up the glass of the car. You just wind it up. Why? It's creating what? Friction. It's opposing the motion of the car. And check it out. Let me burst your bubble. That is why generation millennial cars, they don't do them like our what? Beautiful Volvo cars of those days. I know a Gen Z generation cannot relate with Volvo. Maybe you see it on the computer. Just type, Google it, Volvo, and see what Volvo looks like. This is how cars were before. And it was discovered in the millennia that what? This guy will face plenty friction because of how the surface looked like. So what did they do? They did streamlined bodies. Cars that are now what? Streamlined. Meaning that the air, opposition to motion, the air can just now move and slant on top of the cars. Go and check the new generation of cars now. They don't do 4-corner cars here. That is why your big truck, no matter how much they are speeding, you have a small car, beats and dust what? Trucks by far. The speed of trucks can never be what? Up to those of cars. This is the reason. So for every force that is causing the car to move, you will have an opposite force, which is known as frictional force. So this is what Jamb want to ask you the first time. Whenever force encounter force, there must be a resulting force that will happen. Naira minus naira, we give naira as the change back. You have 5 naira. I collected 5 naira from you. You will have 0 naira. It's still naira that is what? Coming out of it. So what do we now see about this? We said that what? Mixing second law and third law together. Normally, F should be equal to MA. Normally, this is what we are supposed to have. M should be equal to MA. But we are now having an opposite reaction coming from what? Newton's third law. As such, instead of having ordinary F here, we now said F minus FR is equal to MA. F minus FR is equal to MA. F minus FR is equal to what? MA. This formed the basis of what? The first formula. And what type of question will come under this? I think it was, I can't remember the particular year in your Jamb past question, but this is how the question is structured. They said that what? A car moving with a car of mass, a car of mass 30 kg moving with a force of 250 Newton. A car of mass 30 kg moving with a force of 250 Newton has an acceleration of 4 meters per second square. Has an acceleration of what? 4 meters per second square. Calculate its frictional force. Calculate its frictional force. Okpari. A question like this, you are not scared. You know exactly what to do. We are talking about horizontal motion. Car moving what? On an horizontal surface. As such, we are simply saying that what? Our mass, M, is given as 30 kg. Ordinary F is given as 250 Newton. A is given as 4 meters per second square. It is our FR we are asked to find. And using the formula here, we say that F minus FR should be equal to MA. From here, 250 minus FR will be equal to 30 times 4. From here, 250 minus FR, we are dealing with 120. Collecting like terms, 250 minus 120 is the FR we are trying to find. And from here, 130 becomes our value which we are looking for. Shikena. You have something like this, you are good to go. You are done and dusted with the question. On to the next one. Why should simple questions like this come out and you are like, oh, which formula am I going to be using? Be honest with yourself. Do we have F minus FR under the laws of motion? No. We don't have it specifically. When you look at your laws of motion, you don't have F minus FR there. Based on the 3 laws. It is now the application of the law. What they emphasized most, talking about our secondary school days, was the kinematic part, equations of motion, considering motion without the force. We don't pay attention to mass at all, force under equations of motion. Just calculate velocity, speed, velocity. Yes, ma. Okay, man, that won't work because look at it. Remember, whenever you are moving any value from where it is to the other side, the moment it's crossing your equality sign, the sign will change. Once it crosses the equal to, we have plus 120 here. Once you move it to the other side, plus changes to minus in front of your 120. Do you get it? We have that what? It will change. And watch closely. You will see that your FR has minus when it was on the left-hand side. Your FR has minus attached to it on the left-hand side. See what happens when I brought it to the right-hand side. The minus disappeared. It is now positive on the right-hand side. Do you get it? Okay, beautiful. So, look at it. Shikini, simple and straightforward. You already have the first one taken into consideration. The second one. Now, it's for you to know that under this part, you now have some attache being thrown at you. What are the extra jargons that they want to throw at you? It's for you to say that what? Okay, you have F frictional force. Another way of calculating frictional force is multiplying your mu and your R together. Where we have that your mu is your coefficient of friction. Your coefficient of friction. And you have your R as normal reaction. Sometimes some textbook use alphabet N. Anyone, whether R or N, it will work. We say normal reaction under horizontal surface